Okay, so today we'll try to understand the hypergeometric distribution. Now, in this particular case, as we can see, the hypergeometric distribution is given by probability of x is equal to x is equal to k c x n minus k c n minus x divided by n c n. Now, in this particular case, n is the total number of objects and k they are the objects which are classified as successes. Then n minus k is known as the failure, and small n is nothing but what? The sample that you take out from the total n number of objects randomly and without replacement. This is the mean and variance of the hypergeometric distribution. Now let us try to understand how to solve the example on this hypergeometric distribution. Suppose we are having some 100 parts from a local supplier and 200 parts from the supplier from the next state, and we have selected 4 parts out of this randomly and without replacement, and we have to find out the required probabilities. The first probability that we have to find out is that all these 4 parts they are from the local supplier. In the second, we have to find out what is the probability that 2 or more parts are from the local supplier, and in the last part we have to find out what is at least one part is there from the local supplier. So first one is all the 4 parts from the local supplier. The second case 2 or more parts, and in the third case it is at least one part. So we'll write down the data first, which is given over here. Now suppose that x is the number of parts from the local supplier, then we know that this capital N is the total number of parts. 100 will be from the local supplier and 200 will be from the supplier from the next state. So total number of parts which are there are 300. Out of this we have taken a sample size of 4. Okay? So you can see over here 4 parts selected at random. So small n is equal to 4. Now getting the part from the local supplier is our success. So k is equal to 100 because 100 parts are there from the local supplier. So as we have seen, first we have to find out what is the probability that all the 4 parts that are from the local supplier. In the second case, 2 or more. So 2 or more, so it is x greater than or equal to 2. That probability we have to find out. And in the third case, at least 1. So minimum is 1. So again we have to find out x greater than or equal to 1, that probability. So in the first case, we have to find out probability of x is equal to 4. So using the formula, probability of x is equal to kcx n minus k c n minus x, and divided by n combination small n. Substitute the value of k. K is what? It is 100. So 100 c 4, small x is 4 in this particular case. This is the value of small x. Similarly, substitute the value of n, that is 300. K is 100, and again small n is 4 minus 4 divided by capital N is 300 and C 4. So if we solve this, we'll get the first answer, that is 0.01185. Now in the next case, we have to find out what is the probability of x greater than or equal to 2. So that will be nothing but x is equal to 2 plus x is probability of x is equal to 3, and so on. This should be plus, or you can say that it can be written as 1 minus probability of x is equal to 0 plus probability of x is equal to 1. So this is, first we'll find out probability of x is equal to 0. So in place of x substitute the small, in place of small x substitute the 0, so that, and substitute all the other values, so that you will get the first value, that is 0.1955. Similarly, probability of x is equal to 1. So in place of small x, again substitute 1, so that you will get the value of probability of x is equal to 1 as 0.397. Now from 1, if we subtract these two values, okay, then you will get probability of x greater than or equal to 2. and that required value is 0.4075. So that is our next answer. Similarly, if you find out, if you want to find out the probability of x greater than or equal to 1, then it will be a probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is, and so on. Correct? It should not be plus minus over here. Or we can say that probability of x greater than or equal to 1 can be written as 1 minus probability of x is equal to 0. This value already we have calculated. So 1 minus 0.1955 will be equal to 0.8045. So in this way, we can find out all these three probabilities. Okay, so as we have already seen, in case of the first case, the value of x is equal to 4, value of small n, that is the sample size, is 4. Successes is 100 from the local supplier. If we are getting the part from the local supplier, that is classified as a success, and total number of parts, that is capital N, already we have seen that it is 100 plus 200, that is 300. The probability density function or distribution function will keep it as false while solving the example in this using this Excel. Now we'll put the cursor over here or over here for the first case. So this particular cell will give us the answer for our first case. This cell will give the answer for our second case, and this will be for our third case. And we have already seen how to find out these particular answers, but now we'll use Excel to find out this very easily. So go to the formulas, go to the statistical function, then we'll have the hypergeometric distribution over here. Now for this sample small s, that is nothing but x, we'll select this row. Then again we'll go over here, we'll select B2. Then for k we'll select 100, that is nothing but B3 cell. Then for capital N it will be B4, and cumulative we are putting it as false, so that will give you this particular value. So you can see over here, this is hypergeometric distribution B1, B2, B3, B4 and B5. So these values we have already written over here, and we have already selected those values, and we are getting the required probability, that is 0.01185. So that you can compare with the value that we have already calculated by our regular calculations. So this is the value that we have obtained. Now we'll go to this particular cell. Again go to the more functions, statistical functions, and search for the hypergeometric distribution. And again now we'll start with our selection part. So C1, C2, C3, C4 and C5. So in this case we are finding out probability of x is equal to 0, and that value is 0.1955. Similarly, here now we are finding out probability of x is equal to 1. So again go to the functions, then hypergeometric distribution. Start with this D1 cell, that is x is equal to 1. Then D2, that is small n, is 4. Then k is 100. Similarly, capital N is 300, and cumulative false. So that we will get this particular value, that is 0.39705. And now, if you remember, the answer of our first case, that is probability of x is equal to 4, is 0.01185. Similarly, this is the probability of our second case, that is 1 minus in bracket probability of 0 plus probability of 1. So this is the probability of x is equal to 0. This is the probability of x is equal to 1. If we subtract it from 1, we are getting this probability of x greater than or equal to 2. Similarly, if we want to find out what is the probability of x greater than or equal to 1, then we have to subtract this particular value, that is C6 cell. So 1 minus C6 will give this required value. So these are our required answers. First answer, then this is second answer, and this is the third answer.